moving on to page 198 in our journal. We're gonna move away from common variables to think about GCFs, the greatest common factor that a product could share. And forgive me if I'm kind of jumbling up my speech here. I'm thinking about things as I'm talking. So we're going to tell whether the expressions are equivalent. So we're going to kind of analyze these and make sure that they are equivalent or the same. So if we have an A plus a B being multiplied by 8, would that be the same thing as saying that 5 is being added to 3 of A plus a B? Now, if you think back to an earlier lesson where we made the little tile representations, this would be like saying 1, 2, 3, 4, 5 plus 3 of, let's say A looks like that and B looks like this. 3 times A plus, I did that wrong. Here's an A plus a B times 3 of them. So A and B and A and B. All right, so would this whole amount be the same as saying 1, 2, 3, 4, 5 plus 3 of A plus a B? We don't have enough B's here. We had 3 B's over here. We only have 1 B here. Those are not equivalent. For 17, if you want to go ahead and compare these, again, this would be like 5 and then 3 of A plus B, just like before. I'm just making a line look like A. Like, let's say A is a line and B is a line that direction. That's all this means. And 5 was 5 dots. So I'm just drawing models. Is that the same as 5 plus 3 of A plus 3 of B? If we recombine these together? Yes, it is. All right, so here's the answer here. No? Yes? Yes? No. So the greatest common factor now down here, this is where we're going to move into the GCF. Of 2 or more numbers is the greatest number that is a factor of all the numbers. So for example, when you try to find the greatest common factor, you kind of have to look at your 2 numbers. So if you're looking at a 48 and a 32, and you list all of their factors, you would see that they both share 16 as the greatest factor. They share 2s and they share 4s and 8s, but 16 is the best factor because it's the greatest. So 16 is the greatest common number, or greatest number. So 16 is the GCF. Find the greatest factor. So here we have a 12 and a 15. If you were to break all the factors down for each of these, you would find that 3 is the GCF, the greatest. For 24, it would be 12. That's the greatest. Just 1 here. 14, 6, 15. Okay, here's where it gets a little tricky. So you're going to write each sum or difference as a product. First, we're going to write them as a product by using the distributive property to pull out the greatest common factor. So instead of pulling out the variable that they would be sharing, let's say it was AC plus AD, instead of pulling out the A and just saying A times C plus D, this time we're going to pull out a common factor, the GCF, okay? So we have a 63 and a 54, so we're going to break the 63 down into 9 times 7 and 54 down into 9 times 6. So 9 is the greatest common factor they both share, times 7 plus 6. Here we have a 63 minus 56, not 54, which is 7 times 9 minus 7 times 8. And here's our new expression, 9 minus 8 multiplied by 7. Here we have a 7x and a 35. So the only thing I see that's in common is a factor of 7. So 7 times x, we're just splitting these apart to see it clearer, plus 7 times 5. 7 is our common factor. We're going to put that here and just put the other two in the parenthesis. Here we have a 24 and an 18. So they both have a greatest common factor of 6. So what's the other factor that gets multiplied by 6 to make 24? 4. And then just put that x with it. So here it's like saying 6 times 4x. So we're just distributing that 24 out into two factors. And we want to be sure we pick factors that will contain a GCF for the 18, which is 3, right? So then we say 6 times 3y. Now the reason these are 6 is because that's the factor we need to multiply by the 3. So we're going to end up with 6 being multiplied times 4x plus 3y. So this is where it gets a little more complicated, but once you get the hang of it, it's not bad at all.